Okay, so if you look at some of the homework, number 35, you have the population of waist size of men. It doesn't say how old or anything, so all men. And this is a sample of size 250, way big enough. So as long as it's random, and this is not even close to 10% of the entire population of men. So the distribution of X bars, our conditions are met, so we can make it. So this is X bar, and that's that. Here's a histogram of their measurements. So describe this. Waist sizes. It's pretty symmetric, maybe slightly skewed this way. Center around 35 or so. Standard deviation. Well, it's right there. To explore how the mean might vary from sample to sample, they simulate drawing many samples of size 2, 5, 10, 20 with replacement from the 250 measurements. Right, so here's 250 measurements. You're going to randomly pick measurements from here and make histograms out of them. Right. So now you're going to say, okay, if I made samples of size 2, that will be okay because this thing's basically bell-shaped looking. Right? Now the bigger the sample, the tighter the cluster, but the average is going to be about the same, so somewhere around 36. You look up here, okay, 36. Here's samples of size 2. Here's samples of size 5. Here's samples of size 10, samples of size 20. Notice the bigger the sample, the more tightly clustered these guys are, okay, and the more bell-shaped it becomes. That's it. Okay, the number 37, given a table, okay, so measured the waist size of 250 men to study body fat. Here's the true mean for the waist sizes for 250 men. Okay, same numbers as before. All right, draw these, and here's the actual numbers from those samples. Notice the mean's really close to that, and here's the standard deviations. Now these are the actual values. They went and measured, found this based upon using a computer to get them. So this is the actual one. Now the question is, okay, what would the CLT expect? So the theoretic mean should be 36.33, should match the population. Now the standard deviation is going to get smaller based on sample size. So you take the population standard deviation and you divide by the square root of sample size. And you can see as sample size gets bigger, the standard deviation gets smaller. So the experiment was 2.855, 2.84, 1.8, 1.80, really close. 127, 127, 0.895, 0.899. Very close. Looking at the histograms in 35, at what sample size would you be comfortable using the normal model? So you go back and look at those and say, which of these guys do you think is normal enough? That one, a little skewed. That one looks pretty good. I'd go with 5. What about the shape of the distribution of waist sizes? What about the shape of the distribution of waist size explains your choice of sample size in part C? It's pretty close to normal. The original shape is pretty close to normal, so sample size can be small. Number 39. Okay. College data, incoming freshmen, the mean of their high school's GPAs, standard deviation, so those are your population numbers, was roughly mound-shaped and only slightly skewed. So your samples don't have to be that big in order to use the central limit theorem. Students are randomly assigned to a freshman writing seminar in groups of 40, so you have a random sample of 40, big enough to overcome the skew, it's random, and it's less than 10% of the entire population of freshmen coming into this college. What might the mean GPA of this seminar group be? Well, the average of the group averages should match population average, so somewhere around 3.4. Okay. Describe the appropriate sampling distribution model, shape, center, and spread. So I would expect the distribution of sample means from samples of size 40 to be approximately normal, with center 3.4 and standard deviation 40 of 0.35 divided by the square root of sample size. Sample size affects the standard deviation of your sample averages. So 0.35 divided by square root 40 and get 0.055. So I expect the standard deviation of sample averages when the sample size 40 to be 0.055. With attention to assumptions and conditions, we check those. Make a sketch. Cool, you can do that. 43. I just think Zach's turned in his homework at this point, so I'll let you guys try this one again, and I'll post some stuff tomorrow, but I'll also add some problems to this assignment. So you want to work on those guys today, tomorrow, and watch out for that invite to a Zoom meeting. Spread the word, and hopefully we'll see each other's face on Wednesday. Have a good day, guys. Bye.